I commit, I have started the new series, and in the new series, this is Newton mechanics. And as you have seen in Newton mechanics, the first section is FBD, free body diagram. Then the techniques were the question now at rest. You can see in the first section of it. Now here what you can see, when the question of rest, that is called equilibrium. I told you equilibrium will be two type: linear equilibrium and rotatory. Linear equilibrium is total F should be 0, and rotatory equilibrium delta tau net torque equal to 0. So this is called question at rest. And when the question is of motion, so we can write F is equal to m into a, or we can say total F is equal to m into a. This is what you can apply. Now here we can say, if you are talking about the force, this force will be of either weight or tension or contact force. Contact force will be either normal force or frictional force. And frictional force you can see of two type: the static friction or kinetic friction. Fine. Now this is a frictional force type. This is under a contact force. Then spring force may be possible, or thrust force acting in liquids and fluids. Now while drawing the free body diagram, we have to be very particular about the ground. No concept of pseudo force into that. That is called inertial frame of reference. And with respect to accelerated frame, always remember we will apply pseudo force, that you remember, and maybe you have already attempted, and one question that we will see in the following slide. Now the direction, if you're talking about, there are two type of direction is there: horizontal and vertical, parallel to the inclined plane and normal to the inclined plane, radial and tangential, that is in circular motion. And there some directions were there: north, east, west, south, all are perpendicular to each other. And x, y, z, you can say this is orthogonal axis. So x, y perpendicular, y, z and zx. In drawing free body diagram, firstly show that force which are appear as action reaction pair between the bodies. Force, so we can say every mass associated with FBD. Always remember, every mass is associated with free body diagram. So I thought this much analysis you need to do. Fine. Now let's move to the next section, that is called as dynamic. Now under a dynamic section, we can say two agents of the motion. One is called external force, and next is called as external torque. External force, linear vector for a translation motion, and axial vector for rotatory motion. So this is what the two force it will be acting. And as you know, the force or torque it will apply. The force is applied, the body start moving. When a torque is applied, body start rotating. So here we can say basically 5 forces in Newton's mechanics. First is field force, field, then force, acceleration, and acceleration we can say kinematics. So once we are talking about the weight is acting always downward. Tension always away. Tension, let's say the body is there, so it will be from the body, it is acting away from it. Living body, non-living body, both will be acted with it. Tension in Hindi, hamesha हमसे कोसों दूर होना चाहिए. Now contact force due to the pressing. So here we can say normal contact force, as you know, perpendicular to the contact surface towards a body, and tangential contact forces, frictional forces parallel to the contact. So there are two type of normal and frictional, and all are categorized as a electromagnetic nature and electromagnetic forces we can call. Now the third type, it is spring force. A spring force, as you know, some elastic opposite force acting just against a pulling force. And thrust force, always in upward direction. Thrust force, as you know, that is called bound force, always upward direction. And formula is V rho G. V is volume of the body, rho is the density of a liquid, G is acceleration due to gravity. Now this is the problem number 1. The situation is this block is moving downward direction, and once the block is moving downward direction, when the block is moving downward direction, the wedge is moving backward direction. Now what they were asking, acceleration of a block m, small m, with respect to m. With respect to m, this is the big hint for you कि both will be accelerating. Let's say this is moving with acceleration a, this is a2. So firstly draw the free body diagram. As you can see, the wedge will be having acceleration a from right to left, and it will acting normal reaction by the small block on the upper wedge block. The mg is also acting on it, and mg is downward direction. But since we are talking about the horizontal direction, we can account n cos theta, one component horizontal direction, is equal to m into a. This is equation number 1. Now equation number 2, for m1 we will draw the free body diagram. Always remember, where the mass is there, the free body diagram supposed to be draw of that shape, like capital M and small m. Now small m, we can say reaction, normal reaction, and one pseudo force acting, since the lower block is accelerating with respect to it, let's say acceleration a downward, so the pseudo force acting on it. Always remember pseudo force. This is pseudo force. We have resolved the pseudo force into two given directions. Similarly mg get resolved in the two given direction. Now let's say the downward, here we can say y axis acceleration is 0, so that is balance force, and x direction it will having acceleration a2. So perpendicular resultant acceleration is 0, so we can say balance force, and along the incline net force is equal to m into a. This you better to remember with. Now with the help of the given equation, we can say now here we can say, with the help of given equation, we can say a2 is acceleration with respect to wedge. So better to remember these free body diagrams and how we have expressed the given direction of acceleration. This is one of the good question was there. Now let's move to the next. This is also important. When the block is moving with acceleration a, forward direction, fine, in the forward direction. So of course the pendulum initially, let's say pendulum is in a vertical direction, but once it is moving forward, what will happen? It will go further. Let's say earlier it will making angle theta, but for the sake of let me draw properly. Now here we can say now earlier is downward direction, but for the sake of acceleration it will move some point here, and let's say this is making angle theta, that is 30 degree in fact, and this is extra angle theta. So once you resolve, so here we can say this is mg, this is mg, and here mg, because angle remain same, because this line is parallel to the given line, these two lines are parallel, so whatever angle it will form is theta. So mg cos theta, and this is mg sin theta, and since a is also acting, so it would be now this is the given direction. The inclined, once you have adding all the forces together, ma it is acting in mg sin theta, so you can say ma plus mg sin theta. Fine. In downward direction the force it will be acting as perpendicular to mg cos theta. Now as you know the given the total angle from the vertical is, now simply use this triangle and apply the tan theta plus 30 to perpendicular upon base. By the given condition we can calculate the value very easily. Now this theta we supposed to calculate, so we can take tan a plus b formula, tan a plus tan b upon 1 minus tan a tan b. After applying we will get the value of tan theta. So whether this problem is simpler. Now next important question is, this is also one of the important question, where the basic concept is they have given rate of momentum change is equal to force. This is very important concept. Rate of change of delta p upon delta t is equal to f net. By using this concept, so many question it was, this is one of them. Rate of change of momentum they have given as kt, and you have to discover the time, like f is equal to kt during time t, momentum change from p to 3p, you have to calculate that time. So this is a variable type of motion, use integration concept. So dp is equal to k time, integrate 0 to t and p to 3p. By this way we can get the value of t. Now next important, once the air drag is present, so you can say once the body is thrown by velocity u, what is the maximum h? Once the air drag, this is called air drag, and once the body move upward, what will air drag acting? Downward direction. So g plus kv is square, this is the net acceleration retardation acting on a body. So f a is equal to f by m, this is the acceleration downward direction. Now in place of a, v dv over dh. Fine. And variable separate, you can variable separate and integrate 0 to h and u to 0. This is u to 0. So basic integration once you will do, we will get the answer in log form. Now this is also important question. Now in the given question we can say we have given rate of change of mass, that is b v square, that is function of t. Now as you know, f is equal to v relative dm over dt. This is the concept of rocket propulsion. Fine, we have to calculate acceleration, so we can put a f is equal to m into a, that is v dm by dt value they have given as bv square. Now a would be b with v cube upon mt. So this is a vertical direction. One question was there. In the same way, once the force acting and some friction, or we can say some retarding force was there as a function of x, so what you supposed to do, f is equal to ax, that is, and that force is equal to ma. So from where we'll get the value of a. Once again, since it is a variable force, so we have to put value in differential form and integrate, so we can get the value of x. So always remember, when the variable motion is there, you need to be differential form you will use, and then you have to integrate. So this is the basic concept. Force is applying in a body starting from its position vector r at a term t is equal to 10 seconds. So once again, basic situation. Acceleration, now acceleration value once we have calculated look like constant, a constant acceleration, hence we can simply apply equation of motion. When variable is there, we will use differential equation. When the acceleration is constant, we can use a simple equation of motion. So s is equal to ut plus half at, r we have taken initial velocity, it was 0, it is given 0, so r is equal to half at square, put the value of a, and similarly we can get the value of r. Now tip point is, when the acceleration is constant, use simple equation of motion. When the variable motion is there, then you will use the differential equation type of motions. So this is what we can say. These are the important questions where we have seen variable acceleration part. The same time you have seen when the retardation is there, and vertical or horizontal, how we'll deal up, and when some pseudo force is acting. These are the two questions that is based on pseudo force. So I thought this will make your idea very clear. We will meet on the next time to the next following scheduled plan video. Till then, keep doing your hard work, and once you are doing with honesty, it will surely pay off. Till then, take care. Have a nice time.